really hate finding out about mistakes just when it's too late. Like when you cut open a plastic bag and then, oh yeah, there's a zipper thingy right there. Or giving that conference talk and then noticing the giant coffee stain on my shirt. Yeah, that was embarrassing. But nothing compares to shipping your awesome product out the door, having everyone love it, and then getting a major security breach. Oops. Any rocks I can climb under here? Let's just turn off that support hotline, shall we? Hi, I'm Amelia Dalton, host of Chalk Talk. No, you can't just turn off a support hotline when a security flaw is discovered in your device. And there's no way to discover every possible flaw before you release. What you can do is have a plan for discovering and reacting to security issues quickly and effectively when they're discovered. And my guest, Kathy Tufto from Mentor, a Siemens business, is going to explain how to do just that with your next Linux-based embedded system. And before we get started, don't forget to click that link. There you can find even more information about Mentor's embedded Linux. All right, let's go. Hi, Kathy. Thank you so much for joining me.
Yeah, thank you for having me here today.
Okay, so we're talking about Linux security today. But Kathy, before we jump into the details, what do you see are the biggest security challenges in this field in particular?
So, if you're responsible for development of product that includes complex software and connectivity to the internet, then you have many things that you're probably concerned about. Is the quality there? Are there features going to meet the needs of the market and excel against your competition? After time and effort, your team goes out, they solve all these problems, they complete the product, they release it to market, and it's a success. Yay, everybody has a party. But shortly after the product is deployed, you get a midnight phone call from your company's CEO letting you know that the company's product will be on the front page of tomorrow's news because hackers have figured out how to access customer sensitive data from your device.
Okay, so Kathy, what exactly could I have done differently?
What could you have done differently to ensure your device remains secure? The security landscape is one that's constantly changing, with new exploits being publicized almost every single day. This talk's going to discuss the processes that make security vulnerability information available and the mechanisms you should be thinking about before, during, and after your product's development to minimize both the impact and the likelihood of your device being the cause of data or security breaches. Then how to be prepared to swiftly respond in the likely case that some security flaws will be discovered in your device long after they're released to the public.
So, Kathy, that sounds like quite a challenge. What do you see are the biggest security issues at play here?
Well, let's talk a little bit about security vulnerabilities to give you some background information.
Okay.
So, security vulnerability is an error that opens up an application to be affected by some external or internal application that was not intended. Security vulnerabilities are in every single product. Hopefully, by following the guidelines of this paper, you'll protect yourself from issues that are known and make it difficult for vulnerabilities that we don't yet know about to be exploited in your product, giving them time to be discovered and fixed.
Okay.
Security vulnerabilities are often discovered after products are deployed to market. So, this is something that you need to take into account when you're developing your product.
Okay, Kathy. So, how are these security vulnerabilities discovered and then communicated and then finally fixed?
The most important part of this process is known as common vulnerabilities and exposures, or CVEs. When a security vulnerability is discovered, then it is reported to something called a CNA, which is the CVE Numbering Authority. There are around 114 companies that are considered CNAs, and Siemens is actually one of these 114 companies. These companies jointly participate to receive and review the CVE and then assess it to determine if it is in fact a security vulnerability. And given that it ends up being a vulnerability, they give it a score.
Okay, Kathy, let's talk about that CSS score. Now, can you explain that a bit more?
Sure. So when a CVE is determined to be an issue, it's generally assigned a vulnerability score by the NVD, the National Vulnerability Database. This is a number between 1 and 10, and the higher the number, the more serious the vulnerability will be to devices that contain the vulnerability.
Okay.
The NVD also contains information as well, such as links to further describe the issue and fixes that are available for the issue if they exist, and other known information about the issue. The main benefit of the CVE reporting process is the knowledge of the issue, of potential fixes, and of the severity and the risk the issue might have to your products. As you probably know, security vulnerabilities can expose your devices, your customers, and yourself to several adverse consequences, including loss of confidential business data, exposure of customer or end user data, which could lead to identity theft, HIPAA violations, and other serious consequences, or infiltration of the device by malicious actors, which can cause injection of ransomware, etc. Not only are these potential results bad for your customers and their customers, but they're also embarrassing, costly, damaging to you and your company's reputation, and should be avoided if at all possible.
So, Kathy, what are some things that I really need to think about to have the right level of security in my next design?
It's a great question. So it helps think about the different sources of potential security issues. There are things that you know about. For example, you know who is supposed to have access to your device. You know that potentially your data needs to remain private. But there are also things that you just don't know about. For example, we know that security vulnerabilities pop up after devices get deployed. And so you need to have a way to protect your devices from the future. And then if we know these things are going to come up in the future, you also need to have a way to then fix your devices after they're deployed.
Okay.
So let's take a look at this a little bit more closely.
Okay, cool. So, Kathy, different designs have different security issues, right?
That is correct. So, one of the first things you need to do is you need to consider what are the security risks in your device, and you need to come up with a security architecture and then use the many different features that are available with Linux for enabling security throughout your device. And if we look at some of the things that we want to ensure that we're thinking about, the first step is using many of the features that are available with Linux to ensure you start with a secure design. You always consider what your needs are for access control, encryption, and software updates. For example, for access control, have you designed in the ability to define roles that can access various types of data? And are you certain that these roles can only access the data they're supposed to be able to access? Encryption. Does the data on your device need to be encrypted in memory? Are you enabling encrypted transport between your device and others to ensure that your data is protected and encrypted so it can only be seen by those who are meant to see it? Secure software update. So since you know that many security vulnerabilities are often discovered after the devices are deployed, you must be able to securely update your deployed devices. And like I said earlier, luckily the Linux community provides many options for enabling these things.
Okay, cool.
The last thing here I want to talk about is CVEs. And so we've already talked a little bit about how security vulnerabilities can be discovered after devices are deployed, but they can also be discovered while you're working on creating your device. And so it'd be really embarrassing if you released a device with a known security flaw in the device. And so one of the things you need to ensure that you do is while you're developing your product and before you release your product, you need to search for and address any CVEs that affect your product. There are published databases out there that you can search to find known CVEs. Once you go out there and you search, you have to figure out of these CVEs, maybe there's a few thousand CVEs that popped up in the time between you started developing your device and when you go into production. So then you need to filter down and say, which of these apply to Linux? Okay, once you find that, then you need to find out which of these things that apply to Linux impact you. Maybe you find a critical severity issue that shouldn't be in your product. And so then you go and you find that there's a patch to address this, but maybe it requires that you move to a newer kernel. So you need to think about what are you going to do? Can you move forward? Is that even a possibility? Or do you need somebody to backport that fix for you? Beyond that, there's also tools available such as the CVE check tool, which will report to you which packages contain CVEs that are not resolved in the version of the OS that you have. As you can imagine, going through and searching and identifying CVEs that are relevant to your device can be quite time consuming. And most device manufacturers don't actually want to spend their time doing this kind of checking and updating while trying to get a product designed and developed. Most device manufacturers would rather have their engineers solve product problems than manage and maintain a distribution, but you need to have some way to do this.
Okay, cool. Now, Kathy, I would imagine who is granted access would play a big part here. Can we dive into that aspect of security?
Sure. So let's talk a little bit about what Linux provides out of box. It provides discretionary access control. This allows processes to be protected from each other. This keeps, for example, a web server from writing to files that belong to a database without the database granting permission for the web server to do that. Like I said, DAC ships just with out of box Linux, and it works well for many use cases. In fact, nearly all desktop Linux installations rely entirely on DAC as the only security module for the system. But one of the drawbacks to discretionary access control is that the owner of each resource can decide who gets access. And you might not want a resource owner to be able to change access to something on an embedded system. So, mandatory access control is an additional layer of security on top of DAC that essentially says even if DAC would allow the requested access, the program must be acting correctly and only correct access will be allowed. With Mac, you still have users and permissions, but you also have a security policy. And the security policy decides who gets access to something, and it cannot be modified by individual resource owners. SELinux and Mac are two different implementations of Mac that exist for Linux.
Okay, Kathy, so can you tell me a little bit more about SELinux? I'm not sure about that.
Sure, SELinux stands for Security Enhanced Linux, and it was the very first and arguably the most broadly adopted and supported form of Mac for Linux. One of the most compelling features of SELinux is the code size and the way it implements a policy. Also, by default, SELinux allows no access to anything. Now, the implementation of the SELinux policy is beyond the scope of this discussion, but the important thing to understand is that everything, including users, files, network connections, absolutely everything on the system has a security label. The authorization module compares the label against the policy, and if there is an explicit match for those two labels with the requested access, then access is allowed. Otherwise, it is denied. SELinux, when used with a good policy, can protect your devices against both known security risks and future unknown security vulnerabilities. At this point, let's say that we've released our product. So we've addressed all the security issues that were in the product at the time of release. We've enabled security in the device, and we've enabled some way to update the device if we need to address a security issue that comes out later. So congratulations, you've basically done more than most people have to make your device secure. However, once your product's released, your work's not complete. Just because you protected yourself against all known exploits, the number of known exploits increases every day. In fact, over 300 CVEs are typically identified each week. That said, even against the Linux kernel in 2019, there were 170 CVEs, and some of them will lead to exploits or could lead to exploits against your device. While there's no way to prevent this from happening, you need to know that it will happen, and you need to make sure your device is prepared. The time to prepare your device for the future is during development, like we talked about, so that you can prepare the device to be updated as new exploits and also potential product defects are found and fixed. Enabling SELinux can greatly reduce your risk of exposure to future CVEs. As you saw on the previous slide, enabling SELinux can reduce your risk of exposure to future CVEs, but you can't rely on it by itself. You need to continuously monitor for CVEs that can expose your device to attacks.
So, since you're from Mentor, Kathy, I'm curious, what does Mentor offer in this realm?
So, as you've learned, having a security vulnerability monitoring process is an extremely important part of designing your product. At Mentor, a Siemens business, we have a very well-defined, highly automated process. We utilize a central CVE monitoring system that continuously monitors over 50,000 packages and hundreds of sources for security vulnerabilities. Then Mentor creates monitoring lists within the Siemens SVM system, and we get notified of any vulnerability, CVE or otherwise, that impacts one of the packages that's in our products. Once we get a notification, we go through and do a level of impact analysis, and we provide patch or point releases to address CVEs that affect our products that are deemed critical. And then we provide quarterly cumulative patch releases for non-critical CVEs. Mentor can also provide custom monitoring lists and impact analysis reports via our premium support services. So we often have customers that maybe there's only 10 packages they care about, and so we just give them reports based on those 10 packages, which greatly reduces the amount of noise that you would get if you were looking at every possible package in Linux that could have security vulnerability reported against it.
So, Kathy, what does Mentor Embedded Linux really buy me as an engineer?
It's a great question. So, one of the biggest benefits of using a commercial embedded Linux product is that at Mentor, we offer two industry leading embedded Linux solutions, one based on the Yocto project, the other based on Debian. Both solutions are portable across leading hardware architectures and offer commercial maintenance, security vulnerability monitoring and patches, and customization services.
So, Kathy, if my audience wants to find more information about Mentor Embedded Linux, where should they go?
It's a great question, Amelia. To learn more about Mentor Embedded Linux, please go to mentor.com/Linux.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Kathy.
Thank you for having me, Amelia.
Before we go, you didn't forget to click that link, did you? There you can find even more information about how you can keep your Linux device secure with Mentor Embedded Linux. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.